Hey everyone, my name is Cam Louis Nurse. Very excited to be a part of the Neo4j conference. It's been a lot of interesting talks. My talk is in essence around using Neo4j with a container engine called Dagger. I've been doing a lot of experiments with it over the past year and a half. Had opportunities to work with the founder of Docker on it. So I just kind of wanted to share some insights that I've seen when adding Neo4j to the dev stack. I did have a pre-recorded demonstration, which I'll play. It's about 15 minutes. I have a half hour for this talk, so I have another 15 minutes for questions. There are some parts of it because it took about an hour and a half to record all the video footage for the demonstration, and it's kind of chunked down to 15 minutes. So I'll take questions after the pre-recorded demo, where we can kind of dive into the code if anyone had any specific questions as to how any pieces work. Unfortunately, I can't give a live demo, and I love to give live demos. Trust me, I do. But that's because there's been 2 bugs from the past 2 days that have been, not my bugs, but dependencies that I'm relying on. I didn't have time to triage before this talk. So questions, and we can dig into code afterwards. So without further ado, I'll start the video. Hey everyone, and welcome to this tutorial on building automated code quality workflows with Dagger and Neo4j. I'm excited to walk you through this powerful combination of techniques that can transform how you analyze and maintain your code base. In this video, you'll learn how to use Dagger, a modern CI and CD platform, together with Neo4j, a graph database, to create automated code analysis workflow. We'll cover what Dagger is and why it's useful, how to set up both tools, and then we'll dive into a practical demonstration where we build a workflow that analyzes code structure, detects code smells, and integrates seamlessly into your CI pipeline. By the end of this tutorial, you'll have a clear understanding of how to leverage container-based workflows and graph databases to gain deeper insights into your code quality. Whether you're new to Dagger or just about graph-based code analysis, this demo will give you a practical hands-on knowledge that you can apply in your own projects. Let's get started. So what exactly is Dagger? Dagger is an open platform for building, running CI and CD workflows. What makes it special is that it executes everything inside of containers, giving you a consistent, reproducible environment no matter where you run your workflows, whether that's on your local machine, in GitHub Actions, or any other CI platform. Dagger was created by the founders of Docker, and it's built on top of BuildKit, the same engine that powers Docker builds. This means you get all of the benefits of containerization, like isolation, caching, and portability, but with a much more flexible and programmable interface. One of Dagger's key strengths is its language agnostic. You can run your workflows in Python, Go, TypeScript, or any language you prefer using Dagger's SDK. This gives you the type safety and the flexibility to compose reusable functions that define your build, test, and development steps, instead of writing YAML configuration files. You write actual code, which makes your workflows easier to test, debug, and maintain. Dagger also provides powerful observability features. Every workflow is fully traced, so you can see exactly what happened in each step. Inspect logs, debug issues quickly, and because everything runs inside of containers, your workflows are portable. You can develop and test them locally with the exact same behavior you'll see in production CI. For modern development teams, Dagger solves a common pain point: the disconnect between local development and CI environments. With Dagger, what works on your local machine will work in CI because execution environment is identical. This makes it ideal for building robust automated workflows like code analysis system we're about to explore. Now let's talk about setting up Dagger and Neo4j for our workflow. The setup process is straightforward, and we'll walk through the key steps. First, you'll need to install Dagger. If you're on a Mac OS, you can install it by using Homebrew, the command in the Homebrew to install Dagger. Other platforms, Dagger provides installation instructions on their website. Once installed, access Dagger CLI, which is the primary tool for running and managing your workflows. workflows. Next, we'll need Neo4j. Neo4j is a graph database that's perfect for modeling relationships in code, like how files import each other, how functions call one another, how classes depend on each other. For our workflow, we'll run Neo4j as a containerized service within Dagger itself, which means you need to install it separately. Dagger will handle spinning up Neo4j container, managing its lifecycle, and connecting to it. All parts of the workflow. You'll need a few prerequisites. Make sure you have Docker installed and it's running. Since Dagger uses it under the hood, you need access to the code repository you want to analyze. As it's private, you need a GitHub token for authentication. Dagger has built-in secret management, so you can securely pass tokens and credentials without exposing them in your code or logs. The beauty of this setup is that it's flexible because everything runs in containers. You can easily switch Neo4j versions, adjust configurations, and add other services to your workflow without worrying about conflicts or dependencies on your local machine. Dagger handles all of that for you, making the setup process simple and repeatable. Now let's explore the Dagger trace and see what's happening under the hood. This is where the real power of Dagger becomes visible. You see every step in the workflow execution in detail. Right here, we're spinning up Neo4j service. Notice how we're passing in the authentication information and using a cache volume to persist the database data. The cache volume is the key because it allows us to reuse the data across different workflows runs without rebuilding everything from scratch. Dagger provides a convenient method to turn any container into ephemeral service. In our case, we're taking Neo4j container and spinning it up as a service so our workflow can interact with it. This works as any service you need, whether it's a database, a messaging queue, or any other containerized application. Once the database is up and running, we connect to it, a client to it to start sending queries. You can see the Cypher queries are being executed here. The first query is just a simple test to verify the database is responding, so the count of nodes we've created. The workflow then parses all the files in the repository using Treeshape, a powerful library, parsing library. Each file gets analyzed and its structure is captured as nodes and relationships in it. Now let's look at how we interact with the Neo4j service we just created. We're in Neo4j service Dagger module directory. The module contains all the functions we need to manage the database service. To spin up the service, we use the Dagger call command and pass in our configuration file. We also specify the cache volume, which points to the same location we stored in our other earlier data. We provide a GitHub token for cloning dependencies and a Neo4j authentication credentials. To create the Neo4j service function, it takes a container and uses the Dagger convention of passing it as up to create an ephemeral service. You can adjust the verbosity level to see more details in the logs. Setting it to 4 gives us a comprehensive information without overwhelming detail. Now let's connect the credentials we configured earlier. Once connected, we can explore the graph database that Dagger just populated with our code structure. Here, we are in the Neo4j browser. Let's run a simple query to visualize all the file nodes in our repository. As you can see, each file in the code base is represented as a node in the graph. This gives us a powerful visual representation of our entire project structure. The real power comes in when we examine the relationships between the nodes. If I double click on any of the file nodes, you will see that its connections, the relationships show us import statements, function calls, and references between different parts of the codes. For example, file imports from tree modules is referenced by the other files. You can also see configuration files, variables, methods, definitions, all captured in the graph. This graphical navigation makes it incredibly easy to understand how the code base is structured and how different components interact with each other. Now that we have our code represented as a graph, what can we actually do with it? This is where things get really interesting. Let's dive into the code that makes it all work. looking at the Dagger module structure now, every Dagger module has a dagger.json file at its root. The file defines the module's name and the engine version we're using. In this case, our module is called Neo4j. The entry point for our module is defined in the main source file. Here, we use decorators from Dagger SDK to define our functions. Create method is special because it acts as a constructor for our Dagger module, allowing us to pass in configuration, authentication credentials, secrets, like our GitHub token. One of the most powerful features is how we create the Neo4j client. Instead of manually installing dependencies, we define a container with the cypher-shell already configured. Dagger pulls this from a repository, builds it using a Docker file, and makes it available to our workflow. This approach is incredibly flexible because we don't need we need a different version of the client. We simply just update the configuration and point to a different container image. The same principle applies to the Neo4j server itself. We can easily switch between Neo4j versions by changing a single configuration parameter. Containerized approach ensures that our workflow is reproducible and portable across any environment. Okay, so I'm going back to an old run that I did for the smell graph report that I have running in CI. Again, this is open source. I might as well share a URL with you guys now. So if you come to, so it'll be all open source. This is the URL right here. Let's take a look at my actions. Last time it ran was back in September. So if I click on this, you can see it, because we're running in the Dagger execution environment, build once, run everywhere. It's very trivial for you to hook this up to run in CI, and I'll show you guys in a second. But as you can see, my workflow is very simple. I install UV, I install the Dagger CLI, verify my cloud token, I build my graph, right? I run my analysis, right? Because remember, those are just Dagger functions. And then I can look at my smell report, which I can just kind of download or uploads for me. So if I click here, I get I get to take a look at my smell report, and this is the browser version of that report we just saw in the terminal. Let's take a closer look at the code. So I didn't say it was simple, but this looks complicated now, doesn't it? But I assure you, the workflow part is already built. You're just calling the Dagger function. So this is more configuration and wiring it up than it is anything else, right? So we're making sure we have our cloud token. And then, Dagger provides GitHub action. Hold on. I'm not actually using the GitHub action. I'm just installing everything manually. Okay, so this is how I'm installing the Dagger CLI at the version that I want. Checking to make sure it worked. And once I have that, set up my environment variables. Verify my Dagger cloud token, and calling my Dagger function looks exactly the same as what we did in the CLI. So we Dagger cloud, Dagger call, and then we point to the module, right? I guess it does. This is the only part that doesn't look the same. When you run it from your CLI, you don't have to actually point to the module. The pointing to the module is literally pointing to a GitHub repository to a folder that contains a Dagger.json file. So this graph folder, right? If you look, is pointing to here. Well, this is locally on my machine, but it's really pointing to here. Workflows, graph. See where every folder that has a Dagger.json is in essence a module. So you can call it from anywhere. So I'm just saying this same repo, the workflows folder and the graph folder, then I can pass in my parameters as normal. And that's the graph bit. And this is the smell bit. So I build the graph and I run this and I run my code smell. And that's it. And you can wire it up however you want, however you see fit. Like have it run nightly, have it run before you commit changes to your development branch, before you commit changes to your main branch. It's all up to you. Once you build it in Dagger, CI just comes as a benefit. Thank you. All right. All right. You guys survived the video. I guess I'll take questions now, if there are any. Let me hold on. You guys can hear me, all right? Hold on. Where do I see the questions? Chat. Okay. Yes, Dagger is a way to run Neo4j in a containerized environment for testing, prototyping. What's really cool about it is that, it's ephemeral. So if, you can run your experiments and it just kind of goes away at the end. I've also was able to integrate it with LLM agent. So I can kind of show you guys the code for that in a second. I didn't want to present on that, but because, I don't know, I wanted to refine that a little bit more before presenting on it. But in essence, I'm using Pydantic AI as well. You guys saw that in some previous talks. 1 second. So I have an agent that does, that writes unit tests. It analyzes your coverage report and it fills the gap with unit tests. And I actually gave that the ability to give it a Neo4j service, and it just generates the right queries against that. Let me show you how that's wired up. Yeah, so right here, as a dependency, if anyone's familiar with Pydantic AI, I give it the Neo4j service, or I give it a client and tell, hey, you can use this to generate queries to answer questions about the code base once you have your graph created. And it seemed to work well initially, but again, I still need to do a little bit more discovery on that before I'm comfortable presenting on it. Oh, the tech debt detection. Oh yeah, you're right. I actually didn't, the video doesn't include that. Let me show you the tech debt detection part. And I was meaning to cover that. So I had several workflows and I was trying to condense that video down into 15 minutes. To be honest with you, when I initially recorded it, it was an hour and a half. So these are the workflows that kind of make it all work. This graph workflow is responsible for graphing your code base. And the smell workflow is another Dagger module. As you can see, that's a Dagger.json file here. That's responsible for the smell detections. So if you look at it, all it is really is just a bunch of Neo4j queries. So there's no LLM or tokens involved here. They're just, I prompted an LLM and asked it to generate queries for me. So I didn't actually write these queries. I'm actually quite new to Neo4j and Cypher queries, but these are all my detectors that run as part of that process. Again, this was more of a proof of concept for me than anything else. I wanted to see how well Neo4j worked as an ephemeral thing that I can do inside of a CI process. And this is just an idea that I came up with. So this is kind of how the smell detection works. So it runs these queries in parallel. I can probably show a trace on how that works. Does that make sense? So yeah, and so the AI agent part comes in is because you can give, like, you can easily take this infrastructure and give it to an agent as a tool. So you can give the agent, once you have your graph generated, you can give your agent the client inside of this environment, and it can kind of come up with its own queries to answer questions. So it's like an agentic RAG kind of a thing. I didn't demo that. I can demo it. It does actually work, but I figured I can give people the code base and they can kind of go take a look. And where you would actually see that code is if you go into, I have an agent using it, like Cover AI agent. Now this agent is responsible for writing unit tests. And as a proof of concept, I added the ability for it to leverage a Neo4j database to generate that test. So you can see in the dependency, there's like, it has a Neo4j service that it uses to write queries against. So you see you have this query code base tool here. So it just kind of comes up with its own queries based on some clever prompting. So I mean, you guys take a look at the prompt. So I tell it here in the prompt, you know, you can use the run cipher query tool to analyze imports, to understand module dependencies, different prompting techniques I was playing with. Again, I didn't want to include. I thought I had 15 minutes, and I was afraid I was going to run out of time. But that's why, you know, the code repository and everything's included. But great question though. Oh, I see. So can you add the generated graph to an MCP? Can you IDE? Oh, absolutely. One of the cool things about Pydantic AI is that you can take any agent and turn it to an MCP endpoint. They provide a convenience method for you to do that. I haven't tested it, and that'd be interesting, a thing for me to try out. But I don't see why you wouldn't be able to do that. So if anybody's interested, you can head over to the GitHub repository. It's all open source. Maybe contribute to some better queries. Again, I'm a novice at that. The repository is located here. And I'll probably put a link in the chat. So there are 3 repositories that kind of, well, 2 actually, that kind of make this work. There's the actual Dagger agentic workflows repository that has the meats and guts of the code. And the latest branch that I'm on is this one called SpecKit. I tend to do a lot of code or a lot of branch. I know it's bad practice, but hey, I have a lot of experiments going on at one time, usually. And I'll put that in the chat. Okay, put it here. And then there's another repository that I use that the workflow uses to spin up the Neo4j client, and that's this one. It's so simple. And I love the way it's flexible because the Dagger engine provides a way for you to clone a repository. And if there's a Docker file in that repository, it will build that Docker file. So it's like you can have your source code to your whatever it is inside of version control. And as long as you have a Docker file in there, you can point Dagger to that Docker file, and then you can get an actual real life ephemeral thing back. I find that to be a very powerful pattern. Problem is that I would have loved to give a live demo, but the official package for the JDK Docker thing is down right now. So 3 days ago, for whatever reason, they removed some of the tags for the JDK official Docker Hub library. So that coupled with some releases to the Dagger engine is what kind of prevented me from doing some live demonstrations. Reminds me of Superbase branches, paid feature for ephemeral. Yeah, yeah. So I actually have Superbase stuff going on in this repo as well. So I mean, what I like about a Dagger's ephemeral service bit is that, the Docker ecosystem is robust. So, it's almost like you're a kid in a candy store. You can kind of play with anything and prototype anything. So this is how you would install Dagger. But I really love that feature, being able to like spin up a database and spin this up, run a test, and experiment, and then throw it all away at the end. And then whatever you build inside of Dagger, the Dagger engine, you can run anywhere. You can give to anyone to run. Like you guys can actually, because my repository is open source, you guys can actually just install the Dagger CLI and actually just point to my repo and it'll just run. You can point to my repo at a different branch and it'll run that version of the code at that branch. There's so much flexibility there, and I think there's so much power here. But the Dagger tooling is still evolving. The team has been like really working hard at making the engine faster. And I think, once they home in on fine tuning that engine, I think there's going to be a lot of solutions and a lot of demonstrations you guys are going to see start coming up soon with the Dagger tooling. Specifically, I'm more notably known for pairing Dagger with agents. I did a demonstration almost a year and a half ago, demonstrating the power of putting an agent inside of a container. And if you think about it, if you're in a Kubernetes environment, what better than to bring the actual power of AI agents to your environment by bringing them right to the container? So there's a lot of power there. So, and I can kind of show you guys some agentic container stuff, but that's a talk for another session. All right, I think I'm almost at time. If there's any other questions?